Hello everyone and welcome back to our tutorial on Solidity. Today we are going to explore key data structures in Solidity programming, arrays and mapping. Understanding this element is very important for developing efficient smart contracts in Ethereum ecosystems. Before we dive into mapping, let's briefly review the two categories of the data types in Solidity. As we mentioned before, data types are classified into two categories: value type and reference type. Today, inshallah, we will start talk about arrays and then we will move to talk about mappings. Arrays and Solidity are reference type that store a fixed collection of elements of the same data type. Each element has a specific location called an index. There are two types of the array in Solidity. The first one is fixed size array. The size of the array is predefined and cannot be changed after declaration. For more clarification, let's look at this example. In this example, we declare a data1 as array and with size 6. Then we have this function and we assign elements to this array. So as you can see here, data1 can hold up to 6 elements because we have the size 6. And then when we return the data 1, we got this result. We have 10, 20, 30, 40, 50, and 60, which is 6 elements for data1, which is a fixed size array. The second type of array is dynamic array, which are more flexible as they allow the array to grow in size. The size is not predefined and adjusts dynamically as elements are added or removed. Here in this example, data dynamic here in this example, actually we have a data, which is array, dynamic array without any size, but we assign how many values? We have 1, 2, 3, and 4, and 5. So we have 4 values to this dynamic array. And also we declare another dynamic array, which is data1, without assigning any values. So in this function, which is dynamic array, we assign number of values to data1, which are 1, 2, 3, 4, 5, 6, and 7. So data1 now has 7 values. And we can add more if we want because it's dynamic array. Now let's move to talk about arrays operations. Arrays support various operations, which include accessing elements by their index. In this example, we have a contract types. First, we declare an array with size 6. Then we define a function to assign a value to this array. So we have, because we have a 6 as the size of the array, so we should add 6 values, which are here, 1, 2, 3, 4, 5, and 6. So we have a 6. After that, we can have, we can output the array using array elements function. So here we return the x, which is the data2. It means this x will have the value of the third element in the data, because the index here is 2. It means the third element in the data, which is 30. As you can see here, this is the output, which is 30. Also, we can add new elements to the array using push. As you can see in this example, here in this example, we define an array, which is data, and we assign 5 values to this data. And as you can see, this is dynamic array, so we can add more values or more elements to this array using push. Here in function array push, we have data.push 16. It means what? It means add 16 at the end as an element at the end of the data array. Then add 70 to the at the end of the array elements. And then we have 80 as the last element. So as you can see here as the output, we got these elements. Also, you can remove the last element in the dynamic array using pop, as you can see in this example. Here, we have a dynamic dynamic array, which called. Now, let's move to talk about mapping. What are mapping? Mapping in Solidity allows you to store data in the form of the key-value pairs. The key can be enabled data type, except for reference type, and the value can be of any type. Mappings are useful when associating a unique Ethereum address with corresponding values. Let's start by looking at the basic syntax of the mapping. Here we have a mapping, then we have a key, and after that we have a value. Then we have access specifier, which can be public, private, and so on. And then we have the name of the mapping. How we can create mapping? Let's go through practical example to understand this. Here we have a contract called mapping example. And these contracts define a structure called student that holds information about a student, including name, subject, and marks. It also creates mapping named result. As you can see here, this is the result, which is the mapping name that associated Ethereum address with the corresponding student structure. Additionally, it declares a public array called student result to store a collection of Ethereum address. The contract provides a way to store and retrieve student information using Ethereum address as a key. As the mapping is created, let's try to add some values to the mapping. For better understanding, we have this example. Here we have the adding value function demonstrate how to add values to the result mapping by assigning values to the field of the student structure and adding the corresponding Ethereum address to the student result array, as you can see. This is the new information of the student that will be added. Also, we can getting the values. To getting the values, we have added values to the mapping. And to retrieve this value, we must create a function that returns the value added to the mapping. As you can see here, we have this function called getStudentResult. So by this function, we can retrieve values from mapping. Also, we can count mapping, so we can know how many values are stored in a mapping. As you can see in this example, here we have this contract called mapping example. We define a structure and also we creating a map. Then we adding the values to the mapping. After that, we retrieve the values from the mapping using a function. And finally, we can count the number of values using this function and using dot length. For more complex data structure, you can use nested mapping. Here's an example of nested mapping that could be used for an election contract. So here we have this example. In this example, we have a contract called nested mapping. In this mapping, here we have the mapping. This line declare nested mapping named vote manager. This is the mapping first one. And the outer mapping maps unsigned integer to inner mapping. Here we have a unit which is unsigned integer to the inner mapping. And the inner mapping, which is called here, this is the inner mapping, okay, maps an Ethereum address to the Boolean value. This nested mapping allows to storing the voting choice of each employee identified by their address for a specific manager identified by an assigned integer. So this is how we can create a nested mapping. Thank you for watching.